This is video number 2 on the topic motion in a straight line. First, a small discussion. The simplest motion one can have is rest. Consider a car on a straight road. The engines are off, so the car is in this position for all times. Next is the car can start moving. So let it move with a speed of 20 kilometers per hour. So the car is moving with a uniform speed. The next complication is the speed can increase. You see 30 kilometers per hour. And then we say 50. The speed can also decrease. We say 10, and then it can also decrease to 0 and then turn back. So at this turning point, the speed is 0 kilometers per hour. And after turning back, let it have a velocity of say 15 kilometers per hour. But this speed is represented with a negative sign because the direction of this motion has changed. In 1D motion, there are two possibilities. One is in this direction, the other one is opposite direction. So one direction is taken as positive. Here towards right is positive. So this direction, if I take taken as negative, so this speed in the opposite direction can increase to say minus 45, and it can also decrease to minus 5 and then turn towards right. Again at the turning point, the speed is 0. So this turning back and turning towards right can happen any number of times. So this is the most complicated straight line motion one can have. All these things are happening in one single straight line, but just for the sake of understanding, I have shown some gap here. Timestamps are given in the description box. You can watch parts of video if you are running short of time. In this video, I will discuss how velocity and speed of a body are defined, how to calculate average instantaneous values of different quantities. Finally, I will summarize this video. So we consider a body moving from this initial location to the final location here, and let the axis be towards right, and the origin of the x-axis is here. So the initial location, let the x-coordinate be xi, and the final location, let the x-coordinate be xf. So displacement is how far the final position is from the initial position. So here is the final position, here is the initial position. So this distance is displacement, which is xf minus xf. Because xf is from here to here, from this we subtract this distance, which is xi, I'll get this displacement. And distance is the path length. Suppose I take from here to this turning point as L1, and this turning point, the second turning point as L2, and from this point to the final location is L3. Then the path length is L1 from here to here, and from here to here L2, and L2 again from here to here, and then L3. So the path length covered is L1 plus 2L2 plus L3. L2 is covered twice. And the distance from here to here is the distance from here to here, which is L1, and the distance from here to here, which is L3. So this is L1 plus L3. So distance is greater than displacement. So velocity is how fast the position of the object is changing. So the change in the position of the object is displacement by the time taken. So this xf minus xi by the time it takes. And speed is the path length, which is L1 plus 2L2 plus L3 by the time taken. But when there is no turning back, velocity and speed will be same, because if there is no turning back means L2 is 0, because this part won't be there. So in that case, distance and displacement are same. So velocity and speed also will be same if there is no turning back. So this is an example motion. Say there is a car at this location at time t naught, and let the car move to time at location 1 at time t1, and let it be here at time t2, and it turn back, and t3 it is here, t4 it is here, t5, t6 on the negative side of the origin, and t7 here and t8 here. So this is called trajectory of the motion, which is basically the path of the object. So if you take a snapshot at a time t naught, the car will be here. At time t2, the car will be here. At time t3, the car will be here. And time t8, the car will be here. So trajectory is like a sequence of snapshot of the situation. So given a trajectory, one can draw x versus t graph. This is a 1D motion along the x-axis. So only x will change. So how x is changing with time? That's basically motion. So given this trajectory, one can draw x versus t graph. At time t naught, it's at the origin. So this is at 0 point. At time t1, it's at location x1. So this is x1. So this is say t1. So this is at instant 1. So at time t2, it has reached the maximum x position. So this is x2. At a time t2. So this is the second point. At time t3, it has turned back and is reduced. X has reduced to x3. This is t3. So this is the third point. Fourth point, x4 is same as x1. So this is at time t4. x4 is same as x1 for this example motion. And at x5, it's at the origin. x5 is same as the origin. So time t5, this is the fifth point. This is 4. So this is 1 point. And at time t6, it's on the negative side of the x-axis. So this is x6, which is negative. So this is 1 point, point number 6. 7, it's again the origin. So this is point number 7. And 8, it is on the positive side, but it's greater than x1 and x4. But it's less than x3. So it's here, x8 is here. So let this be t8. The time axis is this one. So if I join these points, I'll get the x versus t graph. At time 5, t5 it's the origin, 6 on the negative side, 7 again the origin, 8 on the positive side. So given a trajectory, one can draw x versus t graph. It's a 1D motion, so only x is changing. So the information how x is changing time is basically the motion. One can also go the other way. Given x versus t graph, we can get the trajectory. So there's the same graph I have drawn here. At time t naught, it's the origin, t1 is x1, and t2 has got x2, which is the maximum value of x. After that, it's turning back. So x3, x4 is same as x1, x5 it's the origin, x is on the negative side, and x7 is same as origin, x8 on the positive side. Average velocity is different between two time instances. So if we take, for example, the time interval between t1 to t3, for this time interval, one can define the average velocity. Let me call it v average. 1, 3. So is the displacement done during the time 1, 2, 3. So time t1, this much is x1, it is here, and at time t3, it is here. So this is x3. So in this time interval is gone from this much. So this much is the change in position, which is x3 minus x1, this one. And the time it takes is this much time interval, which is t3 minus t1. So velocity average is change in position divided with the corresponding time interval t3 minus t1. So this is basically the ratio of the two sides of this triangle, and this triangle is right angle triangle because this side is parallel to the x-axis and this is parallel to the y-axis. The angle between the x and y-axis is 90 degrees. So the same 90 degrees will be here. So this ratio is nothing but tan of the angle theta. So this theta is the line angle made with the horizontal line, which is same with the angle made with the x-axis. So this is nothing but slope of the line. Slope of this line, and this line is secant. Secant is a line which joins any 2 points of the curve. That is similar to chord of a circle. For a circle, if you take any 2 points and join them by the line, this is chord, and the greatest chord is the diameter. Similarly, for a curve, if you take any 2 points and join them, that's called secant. So velocity average, or the average velocity between two time distances, is the slope of the secant joining the 2 points in x versus t graph. And speed is the distance in this distance covered in this time interval. So it first goes to x2. So for speed, I will take the path so it's from here to here. So this much is x2 minus x1 from here to here, or x2 minus x1, and from here to here is x2 is more. So this one is x2 minus x3. So it is 2x2 plus 2x2 minus x1 minus x3. Which is different from this x3 minus x1. So this divided by the time interval t3 minus t1 is the average speed in the time interval 1 to 3. Average velocity change in position divided by the time interval. So here it's the time interval is 1 to 2. So corresponding displacement, which is x2 minus x1, by the corresponding time interval is t2 minus t1, which is slope of the secant joining points 1 and 2, which is displacement by time. Average speed is the path length covered in this time interval divided by the time. Average speed is defined between two time instances, but instantaneous speed is defined at any time. For example, at this point t1, you get the instantaneous velocity. From here, I'll take a small time interval dt. So it will go on from here to here, and the corresponding displacement is dx. So this ratio dx by dt is instantaneous speed. This can be defined for any point, any time instant. From here, if you want, at this time instant, if you want to find instantaneous velocity, I just have to go here, take small dt, and find the corresponding dx. So this is dt, and this is dx. So this dx by dt is the instantaneous velocity here. Similarly, here at this point, I'll take small dt and the corresponding dx. So this dx by dt is the instantaneous velocity at this point. So dt is always positive because we are going from initial point to the final point where the time has increased. Here dx is positive because x has increased. Here dx is negative because x has decreased. So here the velocity is positive, and here this dx by dt is same as the slope of this line. Because if I join these 2 points by a straight line, we'll get this line. So slope of this line. But since this point is very, very close, this line will become a tangent to this curve. For a circle, between points 1 and 2, this is the chord. But suppose this point 2 comes very close to this one. So this chord will become like this. And in the limit, the 2 will come here. And this chord will become a tangent. Tangent is a line which touches the circle at one point. So when tangent to a curve is a line which touches the curve at one point. So since the second point is very close to the first point, this secant will become a tangent. So instant velocity is same as slope of the tangent at the time instant. So instant velocity at time t1 is dx by dt at the time t1, which is slope of the tangent at time t1. To get instantaneous speed at this time, you just have to take the magnitude of this velocity. Here the velocity is positive because slope is positive. So at this time, velocity is negative because slope is negative. So this is the tangent here. The tangent here is going up, positive slope. Here the tangent is going down, so negative slope. So here the velocity is negative. Here also is negative. And here positive velocity. Here also positive velocity. Here the velocity is 0 because slope is 0. It's a flat. Here also the velocity is 0. Instantaneous velocity. Because slope is 0. Slope of a horizontal line is 0 because it's not going up or going down. This has got positive slope because it's going up. This is negative slope because it's going down. So this is negative slope and these things are positive slope. Instantaneous velocity at any given time is small displacement delta x with delta t, but this displacement has to be very, very small so that in the limit delta t should tend to 0. In the limit delta t tending to 0 is same as dt. Delta is small change, d is very, very small. So delta in the limit delta tending to 0 is same as d. So delta t in the limit delta t tending to 0 is same as dt. Delta stands for small change, d for very, very small change, and in the limit it tends to 0. Instantaneous speed is magnitude of the instantaneous velocity. To get better understanding of average instantaneous value, let me take an analogous situation. Consider student taking some tests, say 20 tests, and the corresponding marks are M1, M2, so on up to M20. So in test number 1, say the mark is M1. Test number 2, M2. So totally there are 20 tests, and the mark in the 28th test is M20. One way to figure out how the student is performing is take the total of this 20 tests and divide by 20. So that will give you one average. Another thing you can do is take the average of the first 4 tests. Second type of average. So this will give how the performance of the students is changing every month. Suppose assume that the test is weekly test, 1 test per week. So if I take average of 4 tests, that will give me how the performance is changing month to month. And if I look at the individual marks, try to make sense of it, which is how the performance is fluctuating every week. So making sense of the individual values is like instantaneous velocity. But making sense of the average values, average can be for a large time interval or for a short time interval. That gives the average, it's like an average velocity. To summarize, velocity is rate of change of position of an object, that is change in position by the time. Speed is rate of the path is covered, so path changed by the time. Average value is change defined for a small time interval, delta t. Instantaneous value is a change for a very, very small time interval, which is influence of time interval dt. Delta t, the limit delta t tending to 0 is same as dt. You can ask your doubts in the comment section.